Hello, everyone. Good afternoon. I make one promise to you. I will have no Trump jokes for this talk. It's all fun and games, but I have to actually go back to him, and that's just not funny. So my name is Jimmy. You can find me on Twitter at @jbogard. All these talks and everything I do really is on my GitHub, so you can find me on my GitHub, same github.com/jbogard, and I also blog at Los Techies at jimmybogard.lostechies.com. So I want to talk about a topic that is near and dear to my heart. This is also not a Trump joke, by the way. It could be, but it's not. Is the big ball of mud. Now, I know we have microservices, so we can break this up into smaller balls of mud, but I want to really roll back and to see where those original problems came from. And this idea of building really big, complex applications, for me, really came to a forefront when I was reviewing an application for a client of ours. So in this application, it was about as small and simple as it could possibly be. There was just four screens. It had some very basic workflow of approvals of some information. It had some role-based security, so only certain people could approve things, other people couldn't. But to do this, these four screens, there were 20,000 lines of code and two solutions split across 12 different projects to have this very, very basic workflow-based system. Now, this is a system built fairly recently, so I had assumed they were going to be using some sort of best practices around architecture, and they thought they actually were. So I wanted to trace through and see how the system was actually built. And whenever I have to review applications like this, the way I try to understand how everything is built together is I take a single button click in the screen and try to trace it all the way through the system to see everything that happens throughout the single request. So with this application, it started off with web forms, because why not? We can elect Trump, so let's do, I said I wasn't going to do it. So why not web forms? So the single click then went to a code behind page. From the code behind page, it delegated to a service proxy class. That service proxy class then delegated to a WCF service proxy, and it can't be an enterprise application without WCF, even for just a plain workflow application. So then it switched to the other solution. So I had to close this one solution and open up the new one to see where the actual work was being done. So that's where we actually hit the real WCF services doing the work. Nah, I'm just kidding. There's no work being done in here. It was still just passing along to the business, I don't know what the A stands for, application layer maybe? That's what the name of the project was, the BAL. And then finally, that delegated to the data access layer. This was more familiar to me, naturally using type data sets, because if I'm using WCF and ASPX, just go all the way in and go with type data sets. And then finally, where the actual work was being done was in a stored procedure. So this is how you get 20,000 lines of code for an app with four screens. Now, you can look at this and say, of course, I would never build an app like this, but these ideas to build things like this come from somewhere. Now, when I started out in actual .NET development, doing things what I get paid for, the big thing in those days was interior applications. The architecture that we were told to use was something like this. There was your user interface layer, there was your business logic layer, the data access layer, which was, again, usually type data sets because that's what MSDN told us to do. And then finally, the database, which is probably where the actual logic was of the application through store procedures, probably returning HTML and JavaScript from those store procedures. Now, we knew this architecture was bad, and the DDD cobble got together and decided that we don't want this architecture anymore. There's a much better new way of doing things. And so we went to the DDD-style interior architecture, which that's much better, isn't it? It looks like they just changed the name of things, but this is before they had refactoring tools to rename things from data access layer to repository, so this is actually kind of difficult to go through every single file and rename things from data access layer to repository. So this took a number of years to build up this sort of architecture. And so I built applications like this for a very long time as well. The items in my system, the sort of control in my system, was organized by layer. So if I had some kind of business logic dealing with a person, whatever that person may be. And by the way, if you have something in your system called person, you probably need to go back to your modeling sessions because no business ever just calls their customers persons. Doesn't make any sense. And so I'd have at least 4 different things I would have to deal with when having to add any sort of feature to my application. I would have to have some data fields to the person object. I'd have to have something to the person controller. Any sort of business logic, I'd have to put in the person service. And then finally, in the person repository is where I'd have the sort of data access logic in my application. So I took this to pretty much its logical conclusion in a set of very large applications. Now, I should say those applications actually shipped, so I can't say they were totally bad, but I could start to see some cracks in this design. And it really came to a head when I started to have repositories that looked like this. You notice I had to cut off the screen at the bottom. That's because it scrolls down quite a bit farther of all these different methods here. And so I have, in this repository, a lot of different methods that are really only concerned with one specific use. And I saw that this kind of pattern, I couldn't take it any further. I can move some of these methods around. Maybe I'd move them to like a service class or something like that. But again, I wasn't really improving the design. I was just kind of shuffling things around. So we started with a new project about 5 years ago where I really started to try to slam the door in all those old patterns and try to come up with something different. And try to figure out, well, what should I use instead? And reading some of the blog posts at the time and some of the literature, there were a lot of other opinions about how to have kind of better, different layers. Instead of calling them services, you call them something else, helpers or managers or whatever. And you had some platforms that just bake this kind of concept into the system, like Spring, who forces you to create things like repositories and services. So I wanted to get rid of all that. In order to do so, the first thing I needed to do was to get rid of all the patterns in my system, all the patterns in my application, and try to remove all this cruft I'd built up over the years. So that's the first step we did. In the applications I build these days, I really try to have the code tell me when it needs patterns through code smells and design issues, and not try to just put patterns in place just because. And so I went through this defactoring step, where I removed all those patterns and just hard-coded everything into the controller. Now, that's not necessarily where I wanted to end up, but the only way I could really get a good understanding of where my application was and what my code was actually doing was trying to remove all those layers of indirection and all those layers of abstraction. So once I took a step back and took a look at my application, I was able to see that my application really wasn't that complicated in what it was doing. My application had two kinds of things it would do. Most of the applications I have are web apps. In the web apps I build, I'm not as RESTful as some, so I only deal with gets and posts. And in those different kinds of requests, there are only kind of two kind of operations I have. There's a get operation for me to show user some data, and then finally the user would interact with that data through post actions, through different forms, modals, things like that. And it was really only those two kinds of things in my system. At that time, there was a big movement to move away from these layered architectures through a pattern known as CQRS. And that's pretty much what I saw here. When I have an application that gets things, those are queries, and I have applications that manipulate things, or actions that manipulate things, those are commands. So if my application is just dealing with showing data and manipulating data, why don't I try to center my design around those concepts as opposed to artificial layers and abstractions that I had before? Now, CQRS is a pretty simple idea. It doesn't mean I have two databases. It doesn't mean I have asynchronous projected events or anything like that. CQRS is just, I had two models where once I had one, or two classes when I just had one. So I went back and looked at my original repository and said, this is one class that does absolutely everything. But if I take a closer look, I can see some patterns starting to emerge. There are a set of methods that deal with individual queries. Now, each of those methods are really only used in one part of the application. So when I went back and looked at the solid definition, right away, this is a class that doesn't have a single responsibility. You could say it has a single responsibility if that responsibility is data access, but that's not a responsibility from a business perspective. From a business perspective, this has many, many different responsibilities, and each of them are laid out with these individual methods. I also would have commands as part of my repository as well. These were a little bit more rare because I was doing in Hibernate domain-driven design stuff, so I could just have data change on entities and then magically get saved for me behind the scenes. But there were quite a few cases where I'd have commands as part of my repository as well. So now that I had a good idea where these queries were coming from, I defactored all these patterns And for each of these methods, I just took the code that was in there and just put them back where they were actually being called. So shock and horror, I was using ORMs directly in the controller, and Hibernate Entity Framework, it was called directly in the controller. We still ship though, so I guess we didn't anger too many DDD gods with that step. And once I did that, the controllers went back to sort of their ugly looking mess they had before. We had some controller actions that were pretty complicated. They were doing quite a few things to build out the information to be shown on the screen. And then some of them were quite a bit simpler. They would just do one simple request to the database to get information to show on the screen. Occasionally, we would have mixed concerns of business logic and queries as well, where I have to do things like validation or show alternate pages if that resource doesn't exist. I would see those kind of things show up in my controllers as well. Now, on the command side, this is where things started to get pretty ugly because I was manipulating data, and sometimes that logic was a bit more complicated. Even for the very simple case, something like this, by the way, there's not anything in here I recommend, so if you get one thing away from here, do not do anything that you see on the screen with this one action. So many problems with it. This was a relatively simple command and application where I'm just literally bringing in data from the screen, applying it to an entity, and saving that entity to the database. There's really no behavior associated with any of these. There's no side effects or anything like that, so that's a pretty simple one. But we had other ones that were much more complicated. This is one that it was extracted into a different method, but even then it was part of a larger set of methods to do some pretty complicated things on a screen. So I took a step back, and I saw that in my application, I can see that queries and commands are really two different beasts. Queries are really about retrieving data and shaping some sort of result to show it on the screen, and commands are really where that business logic lies. And if I try to build one structure to satisfy both sort of concerns, this is where I get into the issues I saw earlier. And the DDD interior style architecture didn't really solve any of the problems of the traditional interior style architecture. It really just renamed some things, but underneath the covers, it was still pretty much the same interior architecture we had before. So that wasn't going to solve my problem. I needed to take a step back and see how can I center my architectures not around these layers that go across every single request, but treat each request as its own thing in terms of queries and commands. So my next step was to build a concept around queries. Now, when I look at any query in my application, there's always some sort of request for information that includes not only a specific kind of information I'm looking for, but there's also perhaps some input parameters to say, here's how to filter something, or here's some sorting, or things like that. There's always some sort of input request to say, I'm looking for this kind of data. Something gets the data and then outputs it. And so I saw pretty much everything in my application for getting data could be modeled with something like this. There's some sort of input, something to handle the request, and some sort of output. I know this is not like complete rocket science, but it took me way too long to actually realize that this is a valuable pattern to use. I started to see this so much in my applications. I wound up building an open source library to help me build these kinds of concepts where I have requests coming in and then I have some sort of dispatch to a handler on the other side. And we'll get to what this looks like here in a little bit. So back in my super ugly controller here, the first thing I wanted to do was model that request. And that's pretty easy. If I look at a controller action, really no matter what the framework it is, the individual input request is almost always modeled by some sort of method arguments on a controller action. And so those 4 pieces of information, those represent the request of information I'm trying to get, the data. There's also a definition of the information I'm trying to get. So someone's going to the, let's see, this might be the student controller and the index action. So there's always a bit of filtering being done there. And then finally, those 4 parameters make up an individual request. So I would take those input data and model them as explicit classes to say this represents a request for information. And specifically, this represents a request for information for that specific query and not any other specific query. The next thing I do would be to look at the outputs to my application. So how am I taking the results of that query and pushing that information down to some sort of rendering logic to show on the screen? Now, ultimately, output was HTML. So I didn't really want to go that far to say, whatever I have to build around this abstraction is returning HTML as its final result. there is some sort of data in, data out, and then something takes that data in, paints it on the screen somehow. Whether I'm using a single-page application that takes hundreds of megabytes to download, or a simple server-side application that works really quickly. Either way, it's still data being shown on a screen. So I look through here and try to find all of the outputs to the view to be able to be rendered. So things being shoved in this view bag thing, and I also have individual model objects being passed down to the view. And if I take all those things together, all the direct outputs and indirect outputs, I can put them on one individual class that represents, again, the output of that request for data. So with these two things, the input request and the output request, and models that represent the data I show on the screen, I can build out some sort of abstraction to say, here's an input, do some work, and give me an output. And that's what I had here, a handler for a request. I request some specific piece of information, a specific query, and then on the output, I go ahead and return that. And that's all this class is responsible for. It takes an input and builds an output. That's the end of the story. Now, we got a little bit smarter in how we built these kinds of applications. We were having problems with things like ORMs, but we didn't necessarily want to throw them completely out the door. So we used some tricks. I built a library to sort of help me out project these things out into individual results. So in this, for example, this method takes the request output, decides exactly what fields you want on the screen, and passes those into your ORM so that the query being generated is only those fields I'm actually interested in looking at. Now, there's a lot of different ways I could have approached this. I could have just had raw SQL. I could have built a stored procedure. I could have just had, well, anything really, to get that input and that output. The key here is that when I actually get down to the query, it's only then returning back out that information that I'm most interested in. There were some cases where the response of my query could be very complicated, and that was okay, because I would encapsulate all of the response information in that one single place. One of the things I really tried not to do is try to reuse these things in multiple places. For every unique request, I would build out one of these unique response objects, because I didn't want to have any kind of change in one handling and one request to affect anything else. And the only way I could really guarantee that is to have that separation, that physical separation between requests, responses, and handlers. When you start to look at objects like this, they start to look less like behavioral entities, things like that. They look more like DTOs, or even the results of projections from SQL. So they're just a set of data, and that's really about it. Now, if I had more powerful languages, I could do this a lot more easily, and people do that in other languages like F#, but I'm in C#. I'm a consultant. I can't force my clients to use F#. I actually like to have an actual job that earns money. So I have to stick with C#, and so I have to build these sort of classes out that represent the information showing on the screen. I could also do things like projecting a single model. So I have a single student information, and I don't want to pass that actual entity all the way down to my view. So I still project that one entity's data into a dumb DTO that then gets shown on the screen. One other nice thing about this approach is it really eliminated any sort of lazy loading, select n+1, all the really bad things that you hear about ORMs. When you start to deal with the query side as just simple DTOs, then you don't have these problems that people really hate on ORMs for. So on my read side, I try to skip the ORM as much as possible. With most modern ORMs, I can even write raw SQL if I wanted to. My applications, though, the write side can be more complicated, so it's really hard for me to throw out the whole ORM. I try to have kind of a mixed approach, a more compromised approach, where I use the ORM strictly for its good parts and don't use its bad parts. When I have this sort of projection, it executes a single projected query to the database so that I have, again, a very distinct, unique query for that specific piece of information, and that's it. So we went through our application, and we're able to translate one by one all of our queries from the old repository way of doing things and to the new handler way of doing things. Now, the interesting thing is, if I had stuck with a repository pattern, this single object, this single interface that was used across my entire application, meant it would have been impossible if I tried to still use that and refactor to some sort of new way of doing things. Because that one class was being used on every single request, that made it very, very difficult for that one class to change. With this handler-based approach, like this, I could incrementally add these new features and new capabilities to my application and know that I'm not going to affect any other parts of my system. I can also incrementally refactor into this sort of architecture without really worrying about the rest of my system, because again, these handlers are so isolated from anything else, I don't have to really worry about me stepping on any other request toes, so to speak. So after we went through the process of figuring out how to deal with queries, the next part was then going back and looking at commands. Now the command side was interesting. We went through a number of different iterations on our patterns here, and we wound up ending with a almost identical pattern on the command side that we saw on the query side. When I have a command or a query, those are both just requests. I'm requesting to the system to do something. I can request it to read information, or I can request it to mutate information, but on either side, it's still a request. So we wound up going and looking at our different commands and trying to figure out, okay, how do these things look totally different than queries. What are the kind of patterns I'm going to see here across all these different post actions? What is the pattern that's going to emerge here? So looking back at our controller action here, again, this is not how I ever do anything. There's a lot of different problems with this sort of thing. First and foremost is using an entity as the thing that gets bound to with form variables. That has a major security flaw in that someone could guess property names and have those bound up into my entity. And in fact, this is a very famous bug that happened in GitHub a number of years ago, where the developer realized that Rails, or GitHub was built on top of Rails, and Rails had the security hole. They opened up an issue and pull request to fix the security hole by effectively having a whitelist of fields that you can bind against. I guess they weren't responsive enough in that pull request, so this person wind up exploiting the hole in Rails on GitHub to make themselves an administrator of the project to accept the pull request to close the security hole. So don't ever do this. Something like this, if you leave off that whitelisting of fields, then someone could just guess the request variables are going to be bound up against your data object. Then it goes against you need to assume all inputs are malicious and invalid, and this sort of approach doesn't. But this other way of including this bind statement with this string of comma-separated properties, I mean, there's no way that could go wrong, right? I'd never misspell something or transpose letters or forget to put a property on there. This sort of approach is also super testable because it's really easy to go parse a string out, find the properties, and make sure that those are the same properties I was showing on the form and no others. No, I'm kidding. It's a horrible pattern. So we don't do that. It's a horrible idea. In fact, I got this code from the Microsoft sample app. So they provide just kind of really great fodder on how not to write these kind of applications. It's just kind of rife with these sort of problems. But if I just take it at face value, I look at this and say, there's some sort of request to manipulate information, and it comes through in a series of inputs. And again, that's the controller action parameters. Those are the inputs to say, I want to change this kind of information. So I can take that, and instead of saying, let's use a live entity, which has a whole host of problems, not the least of which is entities aren't really good at being data bound from raw request variables. So if I do this, that means that I have to make my entity be serializable to the web, which is, again, a really nasty idea. Instead, I model this as an individual request. That is, a command to do something with the information needed to handle that request. So I just took all the properties that are on the screen and put them in this one simple class. To actually handle the request, I would create again, another request handler to do the actual work. Now in this case, I'm using a nicer way of mapping the properties back in with another library I wrote of AutoMapper. I don't always recommend doing this. It's only the very simple cases you can just sort of shove the data back in. But for this simple case, it worked. But now I can reason about what this business logic is outside of everything else. I can delegate out to this class that only deals with the actual business concerns of handling the request and not worry about things like user interface, that kind of stuff. Now, with this kind of architecture, I still have to deal with things that go across my entire application. These are known as cross-cutting concerns. If I build an architecture that deals with these individual sort of vertical slices of requests and handlers, there's still the case I have to have something that goes across everything else. So if I go back to my controller action, there's something I skipped over, which was checking if validation was successful or succeeded or failed. That's that one line of code right there. I check to see if the validation was successful, and if it was successful, I do the actual work. And if it wasn't successful, then I would show the page to the user with some errors on it, things like that. Now again, this highlights another anti-pattern I really don't like when it comes to these kinds of layered architectures, which is I am using the entity itself as a means of validating an action. So what happens is the underlying MVC framework pokes in all the data into my entity, and then the MVC framework asks my entity after the fact, hey, are you valid or not? And for very simple validation rules, that's okay, but for more complex validation, I need to have some context. What were we trying to do? I just see that you have some required fields, but maybe for this one request, I need to enforce these rules, but for this request, I need to enforce those rules. But I've already mutated my entity, so I can't go back and look to see what the old values were. I've already moved past that, and I have a mutated entity in just a bad state. One of the good ideas of domain-driven design is the idea of an aggregate root being able to encapsulate all of its operations and always stay in a valid state. And so that's what I would do instead. Instead of me having my entity get mutated and then say, oops, I messed up, I would have that being enforced before the entity was able to get into that state. Now that I built these request objects, I can now, instead of validating state of an entity after the fact, when it's too late to really make any difficult business logic decisions, I can validate those requests individually by themselves. So instead of me validating the entity, I would validate your request to do something. So whenever you want to perform an action, I look at the action by itself and say, does this action make sense based on the state of the entity and based on what information I see on the incoming form? I'm using another validation framework here. This one's called Fluent Validation, and it allows me to create a generic validator for a specific type. And the type here could be my request type. So not only do I have a request with a handler, I also have something that represents validating you doing that one individual request. Now, in a lot of my systems, I start to have individual requests have fairly divergent validation rules. So if you have an entity in this state, it's valid to do this. If you have an entity in another state, it's not valid to do that. But perhaps in a separate part of the application, it's okay to make that same manipulation of the data because it's a different request to do something. So with this kind of pattern, I can make sure that my validation rules are tied to a request to perform an activity, and that also makes the conversation with the business owner much easier because I can talk about an individual screen and say, okay, what rules should we enforce on this screen? And really get them out of thinking about entities and rows in a database and get them more focused on activities and tasks and commands. Those are the more important things they need to be concerned about, not about, I need to make sure this row has this sort of validation behind the scenes. Now, the final thing we did with this sort of architecture, we had a lot of different classes in a lot of different places. And we need to figure out how to manage that more effectively. And we wind up doing this by, instead of us organizing our application by layers or kinds of thing, we instead organize them by how they change together. So if a group of classes and types change together, we would place them together. In our original application, if I wanted to make a change to a system, I'd have to go all throughout my folder structure. Over here, I'd have to go make a change to the controller. Oh, over here is my handler, so I got to add a new handler over there. Oh, my view models are way down there, and finally, my views are way down here. So we were jumping around quite a bit. Unfortunately, most most full-fledged architectures, web architectures, still follow this kind of pattern, where I have, if you start a new Rails application, there's controllers, there's views, there's models, and those are all separate from each other. Angular, I think there's about 6 times more things in there. I'm not entirely sure. So we looked at all these pieces and said, how can we make sure that if they change together, they live together? Well, one easy way to do that is just to collapse them all together into one single, and effectively one single file, where I'd have a top-level feature, in this case, dealing with student information, and for a specific request to create something, I would place all the things that deal with that request in a single location. For more complex things like editing something, again, I would have everything related to those requests in this one single class, only one single file, just using a class to sort of gather things together. So if I wanted to see how the specific set of business rules worked and the information being shown on the screen, every set of C# code that dealt with it was in that one single spot, and I didn't have to go around every way to figure out how it should work. We went even one step further. This is all the C# code. We wound up putting all logic dealing with individual requests together. So in this application, I've got not only the edit C# code in the single spot, I also placed right alongside it any view that was associated with those requests, as well as any JavaScript declared as a module alongside that as well. And I don't know why it's like indented and tabbed over. That's just Visual Studio being drunk Visual Studio here. But it's just files that are all alongside each other. Now, the interesting part is this actually made our front-end designers and developers much happier, because before we had like our template code over here, and then we had the JavaScript code over here, and they would always have to go back and forth when they were making any changes. In this case, they can have the HTML directly next to the JavaScript, and when our developers all moved over to React, this is a very natural transition to them, because where before they had the CS HTML server-side template next to the client-side JavaScript with their JSX files, they were all in one. So it was a very natural transition for them. Now, going back and looking at our controller, I can see that our controller is now much thinner and much lighter. It really is just dealing with requests and using those requests to mediate, using a mediator pattern to mediate them to a specific handler for this individual request. My controller itself, though, is about as thin and light as it can be. The kind of logic I see now on my controllers is now strictly UI related and not related to really anything else anymore. So if I have like different kinds of results to return, maybe file results, things like that, I would definitely see those kinds of things here. If I'm doing things like tagging specific controller actions with different routes, or maybe specific kinds of authorizations, those are okay to have here too, because those are strictly user interface concerns. But I'm not trying to then push, I'm not trying to have a combination of all my business logic and whatnot. It is strictly now user interface concern. Now, at this point, I noticed that my application basically had no DDD as part of it. I'd taken basically all of the logic outside of the handlers and out of the actions, and for each action, now there was a single method to do that work. Well, that didn't mean the actual methods themselves were that great looking, but I found that this sort of pattern actually sort of reinvigorated my ability to do DDD, because I wasn't worried about dealing with these patterns and these layered classes that would span my entire application. I can make more drastic changes on individual handlers. So something like this, for example, where I have a normal handler, I found that it was doing really 3 things. It was retrieving some sort of entity from the database, doing some behavior and business logic to do whatever manipulations is needed. If there were side effects, it would raise messages and things like that. And then finally, it would save the entity. Looking at this, I can see that if I wanted to go down the domain-driven design route, it's now a simple refactoring to just move the actual work being done in the handler down into the actual entity itself. Now for simple requests, simple commands, There was no really need to do this kind of stuff. If the handler was very simple, then I didn't worry about it. Just, okay, this code is fine. And what we tell our developers these days is make this code in the handler as procedural as possible. Like, make it as dumb and as absolutely dumb as possible. And only when you're done getting that feature to work based on the request and the response, now I can go take another look and say, how can we refactor that code to make it easier to maintain, cleaner, all that other good BS from Solid, right? So at a more complicated command like this, now I have a lot of logic to get the entity out of the database. This one's a create or edit one. So sometimes it creates it, sometimes it retrieves it. And then I'm actually delegating down to the entity itself to do the business logic behind the scenes. So my handler itself now becomes a little bit simpler because it's only dealing with getting the data out of the database or wherever it needs to come from, and then now delegating off to a more pure domain model to actually do the work. And now my aggregates themselves can handle those commands themselves and not worry about any sort of outside forces. It is about as pure DDD as I possibly could get without a single repository in my system. My final architecture looks something like this. I had a set of vertical slices in the form of features in my application. When I'm adding new features to my application, it's only adding new code. It's never going back and changing anything. So I don't have to worry about the side effects of my actions. If there are some cross-cutting concerns, these are the domain agnostic pieces that are the sort of, I'm not going to call them layers. How about strata? Just some other word. Those domain agnostic cross-cutting concerns that go all across my entire application. But there's nothing business specific in those pieces. The domain specific is the real meat of the request. And so our developers that are working on these applications are truly focused on what's actually important, which is the request of information that the user wants, handling that request, doing some sort of query or command, and then returning a specific result to the end user, and they never have to worry about stepping on anyone else's toes again. So with this sort of pattern, we also found that merge conflicts are much less likely because people are they're much more rare to be manipulating the same files because I'm typically only adding new requests and new handlers to my system. So going back and looking at how this exhibits Solid, well, first of all, the single responsibility principle is actually valid now. We're having one single class to represent each individual feature or concept in my system. And the reasons for change of those are all business reasons, not any sort of structural reasons behind the scene. My system exhibits the open-close principle because I can extend my system through these cross-cutting concerns. If I need to have additional cross-cutting concerns like authorization or logging or things like that, those can go across my entire system and not have to affect each of those individual handlers. On the Liskov substitution principle, we just stopped doing inheritance. There were no base God classes in our system. We had everything being this request and response, and tried as much as possible to not share any of that information or any of those requests across multiple handlers. For us, reuse was a bad word. If I was reusing something, that meant I introduced coupling. And so us avoiding coupling meant it was okay for us to duplicate logic in places as long as it was actually specific to those requests. The interface segregation principle. If you remember my first repository, that was a poster child for multiple violations of the interface segregation principle because it had so many methods that were only used by one individual request. With this pattern and separating queries from commands, I ensure that each individual interface implementation is only used for that one request and nothing else, so I can't ever violate this one. And finally, the dependency inversion principle. We saved for actual dependencies. So something we didn't own, an external web service or something like that, that's what we saved those dependencies for. In our handlers, we said, yes, go ahead and use the ORM directly, or whatever you want to do. I don't even care. If you want to use some different sort of data access technology, it doesn't matter. From the external view, all I see is a request going in and a response coming out do whatever you need to in that handler to get the job done. So in the end, I think we wound up with an actual solid application. And with this, we threw out all of our layers, said no to the big ball of mud, and embraced our slices over the layered architecture. Thank you very much for coming. If you have any questions, you can catch me on Twitter. This will all be on my GitHub. Otherwise, have a great rest of the conference. Thank you.